Hi, ladies and gentlemen, this is Mr. Green, and we're going to start another lesson in my series of lessons on Algebra 1. I'm going to continue talking about graphing inequalities here. And so, you know, if you imagine that you were on a sailing ship, okay, sailors needed to be able to plot their coordinates very carefully so they knew where they were so they could compare it to maps and know if they were coming up on hitting an island or when to turn right so they could hit an island or something like that. So the whole point there is that that's where these coordinate grids came from, was sailors sailing on a ship. And the x coordinates were their left-right movements. And the y coordinates were their forward and backwards coordinates. Okay? So I know a lot of you think of the XY coordinate grid as up and down, where the X is right and left and Y is up and down. Well, that's the way we have to depict it on a flat surface, but in actuality, it's forward and backwards, okay? So don't get confused when you're looking at this and thinking, oh, it always goes up and down. It doesn't. It goes forward and backwards, right and left, okay? So let's look at some graphs real quickly and see what we can come up with. Remember, we start by looking at the y-intercept here. We're going to go to a positive 4. We're going to put a point right there on positive 4. We're going to then look at the slope on here, and it's a minus 3. That means we go down 3. 1, 2, 3, and to the right 1. Okay? We can do that again. Down 3. 1, 2, 3, and to the right 1. We're going to do it again. 1, 2, 3, and to the right 1. So we now have a series of points that we can connect together. I want you to notice that this is a greater than or equal to. That means it is a solid line. So that means when I connect these with a solid line, that is a good thing. Okay? So I'm going to go ahead and put arrows on the end of it here. It doesn't go through 0, 0. So if I use 0, 0 to determine which side to shade, I get 0 greater than or equal to 0 plus 4. Or 0 is greater than or equal to 4. Well, that is false. That means the side that has 0, 0 is not going to get shaded. I am actually going to shade the other side of the line over here. This side over here. Okay? That's how you determine which side to shade. Cool. Let's look at another one here. Minus 5. That's where I'm going to start. I'm going to go all the way down to minus 5. I'm going to put a point right there. I'm going to use the slope, 3 over 5. That means go up 3. 1, 2, 3 over 5. 1, 2, 3, 4, 5. Cool. I can now connect those. Is it a dotted line or a solid line? Well, it'll be a solid line. Why? Because it is a greater than or less than or equal to. Okay? See how it's got that equal to sign in there? That's what you designate a solid line with. So I'm going to stick 0, 0 in there because it's not on the line. And I'm going to get 0 is less than or equal to 0 minus 5. 0 is less than or equal to negative 5. Nope, that's false too. So we will shade the side opposite of 0, 0. We will shade this part down here. Okay? Now, what does this shaded area actually mean? It actually means that any point within that shaded area would be considered a solution to this problem. It's not just one point. It's any points in there, okay? Let me give you an example. This point right there, that's at negative, or that's at a positive 5, comma, negative 5. That is the x and y coordinates. Let's see if that actually works in here, okay? So we say, well, negative 5 is less than or equal to 3 over 5 times my x-coordinate 5 minus 5, okay? Well, 5 divided by 5 multiplied by 5, those will cancel out. And I'll get negative 5 is less than or equal to 3 minus 5. Well, 3 minus 5 is a minus 2. Negative 5 is less than or equal to negative 2. And that's a true statement. So you see, this point is actually in the solution set. That's what it means. Any of the points in here you could do that with. I just happen to pick the ones that are easy to deal with by picking them on this where x is equal to 5 because my denominator was 5. Made it easy to do the multiplication. Okay? Now, how about this one? I've got a strictly less than sign. That's slightly different. So I want to show you how we do this. We're going to go to -5, put a point. My slope is 2. I'm going to go up 2 and over 1. 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 2 over 1. Up 2 and over 1. Hey, all those points are in a line there. But I've got a problem. See how this is strictly a greater than or greater than. That means I need to use what's known as a dashed line. I can't use a solid line on this one. Why not? Because the dash line is telling you that it's not equal to the things that are on that line. It's only going to be in the shaded region on either side of it. It's the way you tell the difference between the two. Okay? So let's go out here and put 0, 0 since that's not on the line. And we'll get that 0 is greater than 0 minus 5. 0 is greater than -5. Well, that's a true statement. So in that situation, I'm going to shade this side that has 0, 0 on it. Everything over here is going to be a solution to this one. Are points on that line going to be a solution? Absolutely not. You cannot use the points on that line because it's a dashed line. It was a strict inequality. Okay? Number 6 here. It is an greater than or equal to sign. So we will be able to use the line this time. So we're going to start at 2. We're going to go, let's see here, we'll go down 7 and to the left 4. 1, 2, 3, 4. Now, I'm not trying to confuse you here, but I can't go up 7 because I run out of space. So using two negatives works here, going down 7 and then over to the left 4 gives me the same line as going up 7 and over 4. Okay? So I'm going to draw my line here between these 2 points. It goes like that. And put my arrows on the end of it. Okay? And it is a greater than or equal to, so it's a solid line. I'm going to stick 0, 0. See it right here? It's not on the line, is it? So 0, 0 in here is going to be 0 greater than or equal to 0 plus 2. And that means that 0 is greater than or equal to 2. No, that's not true. So I don't want to shade the side that has 0, 0. I want to shade the side opposite it over here. Okay? See the difference between these two? This one over here has that pointer, thank you. This one has the dash line. You knew that it was a strict inequality, a greater than. This one has the greater than or equal to sign, solid line. That's the difference between them. That's how you can tell them apart. Okay? Now, I did all these yesterday, or when you watched this the other day, and I did these last two wrong because I didn't catch the fact that they had these inequality differences here. The difference is these two up here are going to have solid lines. These two down here are going to have dashed lines. You need to make certain you recognize that difference, okay? I want to make certain I'm clear on it. It makes a huge difference in what you graph. Okay? Okay. Well, I'm going to save this for now, and I'll talk to you next time.